Hello, welcome back. This is the Regainity demo video of May 25, 2026. Today we talk about version 1.3.0, which was already released yesterday, but I needed some more time for creating the material for this demo video. This release was mainly about stability and putting things on a sound foundation. So there are not so many things visible, but one of them is that we can create new text secrets now. Before we could only upload files. Now we can also create them ourselves. So we have to give it a name now, secret, and we can start typing. You see there is an error message which tells us that the text must be more than 20 characters. This was a bit a compromise. So let's say if something is too short, too small, it's not really safe in encryption. And we had three possibilities. So we could, or three ways, we could have made the algorithm more complex. We could annoy the user a bit, or we could make it less safe. And less safe is not an option. And so we decided here that annoying the user is maybe acceptable for a bit more of security. And anyway, no one wants to store something really small. It's probably more about the upper limit of the document size. So hello, this is a secret. Once you pass the 20 characters, the error message disappears. You can save it, and now we have it and it's saved, and it's also uploaded to the server. Now this is new as well. We have a decrypt button, and this was also a very conscious decision that we never want to decrypt something by default. It should always be explicit that the user requests it. It could be that the user doesn't trust the device he or she is working on, or whatever reasons, maybe don't trust yourself. So let's say we load the documents maybe in background, but we don't decrypt them. That is done once you press this button, and here you have it. And there's something you might have to get used to. So since we use the password, so I now reload the app, and so it knew the password because I logged in before, and now it doesn't know the password. And if we try to decrypt it again, now it goes into a password recheck. And this is because we need the password for the decryption. We can encrypt without a password, but for the decryption we need it. So we use the password manager, that goes fast. And now with the password we can decrypt it again. And I thought that it's kind of important for trust that we explain how we do it. And that is now the reason for that the second part of this video, that I make a bit of an explanation about our security concept. So one thing is we want to be a zero knowledge platform, which means that the user data and the secrets of the users are encrypted on the user's device, in the client, which is in our case here the web browser. And the data sent to the server and stored there should not be or cannot be reconstructed by anyone else than the user. And there would have been, I mean, not by us as the platform operator or by anyone who has access to our backend, which could be a government or some hackers. And there would have been several options how to do it. We could have used some things connected to the device of the user. We could have used biometric data. But at the end, we thought that the password is most connected to the will of the user. You could use the biometrics and the device without the consent of the user, but the password is kind of connected to consent, to will. And so the decision is to use the password, the same password you log in with, as a base for all encryptions. There's a slight little problem though, that passwords, because they are so short, they are not safe enough. So they have limitations, and we have to overcome them to make it secure again. And so the core concept is that we generate a personal key for the users. That happens when you log in for the first time, or if in this time it fails, it can also be done later. And the personal key is an asymmetric key, which means that it actually has two parts: a public key, which is used for the encryption, and a private key, which is used for the decryption. And so the public key is not a secret at all. Anyone could have it, anyone could see it. Actually, anyone could be, with the public key, anyone could encrypt things for us, and we are the only ones who can decrypt, as long as we keep our private key secure. And that is what I will explain now, how we try to keep it or to store it in a way that only the user can access it. The public key we store like it is, and with the private key we wanted to do something with the password, so we use the password and the private key and encrypt it somehow, and then we can store it. And we do this using a method which uses a salt. A salt is the lingo of in cryptography. It's just a big random number which is to make it different each time. Even if you use the same password again, the salt ensures that each time you use it, it leads to a different result. And the whole method, so in which we derive our password, is also kind of expensive, which means actually we don't do this whole method once. We do it 600,000 times, or even more maybe in future. And that it's expensive in the way that it needs like half a second. And for us, it's maybe a little annoyance that we have to wait a bit. But for someone who wants to make a brute force attack, that would be maybe a limit which is difficult to pass. So because someone who wants to make a kind of derivation for every possible password has the same complexity, and this complexity will maybe, I mean, if in a normal circumstance you would need 1 year to find our password, maybe now it would be 600,000 years, because we do the thing 600,000 times. And so we use this method to get a derived password, and this derived password is like now a good key to encrypt our private key. So this is what we use to encrypt the private key, and then we can store it. And of course we also have to store the salt, which later will be needed to reconstruct our derived password. And now where we go about retrieval, it's easy for the public key again, we just take it out. And for the private key, it's a bit more complex. We actually need the salt again and the password. We derive our derived password, and then we can use it to decrypt the private key. And actually, I show this here in one graphic, but actually, since the public key is used for the encryption and the private key is used for the decryption, it's never used together. So it's not happening at the same time. It's happening at different times. But this also shows that you need the password only for the decryption, not for the encryption, because the public key doesn't have the password anywhere inside. And now it's unfortunately this is not everything. So actually, the way, I mean, we use a bit more techniques to encrypt our documents, our secret documents. So this is what we want to achieve. We have a document, we want to encrypt it and then store it in the database. Actually, we do this with an random, cryptographically random key, which is a big random number we use as an encryption key, and it's generated when we generate the secret. But somehow we also have to store the main key now, and we have to encrypt it for storing it, because that is what is later be needed for accessing the document. And for doing this, we use the public key. Well, what we explained just before, we use the public key. We encrypt our main key, and since only the person who has our private key can decrypt it, that is now a safe thing here to store. Yeah? And we have the encrypted main key, the encrypted document, and later we could, only the owner of the private key can later decrypt it. Yeah? And now I show how that works. Yeah? So we have the document encrypted and the main key encrypted. So somehow we want to use the main key, but we first, before we can use it, we have to decrypt it. Yeah? And the main key will be decrypted with the private key, but which is encrypted as well. So we have to do the whole process with the password and the salt. Yeah? Get the derived password, decrypt the private key, decrypt the main key, and then we have the decrypted document. Yes, I hope that was kind of interesting and it was not too complicated, and I would be happy if you come back to the next video, hopefully in 2 weeks. See you.